Hey guys, welcome back again. It's Mr. A here with another edition of Algebra 2. Today we're in Chapter 6, Section 5. We're going to be talking about operations with radical expressions. Some of this is going to be similar to what we did in the last lesson, and then we're going to kind of take it ahead a little bit here. But here we go. Let's sit tight and hang on. Here we go. Our objectives for today: simplify radical expressions. Some of that's kind of what we had done before. And then add, subtract, multiply, and divide radical expressions. So let's see what we got here. First of all, the product property of radicals. Basically all this stuff says here is that if you have, like in this first example here, two radicals being multiplied together, as long as they have the same index, in this case they're both square roots, you can multiply those together under the square root. So 2 times 8 is 16. And then you can take the square root of 16, which is 4. It doesn't say this here, but if there are numbers outside, those can multiply together. But you cannot mix them up. You can't multiply something on the outside times something on the inside. Okay, so keep that in mind. But then also if they're I guess this is just another example of that here, is that they're broken up into two parts. You know, you've got a cubed root and a cubed root. So that means since these have the same index, then what's underneath can get multiplied together. And you can take the cubed root of 27, which is 3. Likewise, you can do the opposite of that. If you have a number, and we've kind of done that before to break the radicals down, if you've got a number under here, you can break it down into two things being multiplied together and do each one separately. So we kind of know about that a little bit already, but that's the product property of radicals. So let's look at a few situations here. Let's just work on a few things here. Alright, so first of all, we got this square root of 25, a to the 4th, b to the 9th. This is the kind of stuff that's pretty much like last time. We're going to, with the product property, you know, we can break this down, like I said, kind of split it up into certain parts. So we can split this up into square root of 25, square root of a to the 4th, and square root of, well, we got square root of b to the 9th, but we know that's not going to divide out evenly. Remember that last time? So I'm going to change this to b to the 8th times b. So together, here's b to the 8th, and there's one more, so that's b to the 9th all together. So I also split up the b to the 9th there. Well, what's square root of 25? That's easy. 5. Square root of a to the 4th. This is last time we talked about this, and remember, one easy way to do this is you just take whatever your exponent is in here and divide it by your index out here. So 4 divided by 2 is 2. So this would be a squared. And the reason why I split this up was because if you did 9 divided by 2, it doesn't go evenly. So I split this to make this 8 divided by 2, which is b to the 4th. And then square root of b we can't do anything with, so we'll just have to leave that as square root of b. Okay, you should kind of remember some of that from last time. Alright, let's look at the next one here. A little more difficult because of the cubed root, but we can follow the same procedures here. So first of all, let's split this up. We have the cubed root of 125. This time I've got my calculator up here. So turn it on here. The cubed root, remember what we can do here is I can go to math, and down here number 4 you see is the cubed root. So I'll hit number 4. I guess I got to type in number 4 there. Number 4, we have the cubed root of 125. So, that works out evenly. So that's 5. So this is going to be 5. It's interesting. The same one as up here. Then we're going to go the cubed root of m to the 30th. Will that divide evenly? 30 divided by 3? Yeah, it will. So we don't have to break that up any further. 30 divided by 3 is m to the 10th. Nice. What about the p? 20 divided by 3, that does not go evenly. So we're going to want to break this one down a little bit. So what can we break it down into? Well, we want something to divide by 3 evenly that's less than 20. Well, 19 won't go, but 18 will go. So we've got the cubed root of p to the 18th. That'll go evenly because 18 divided by 3 is 6, right? But we still have something left over. What do we have left over? We still have 2 more p's here, so we still have the cubed root of p squared. And so that's what we're going to just leave in that form. So we have the cubed root of p squared. Yeah. A little weird on the corner there. All right, kind of getting a feel for that? All right, next. So now, on this slide here, we've got the quotient property of radicals. We've kind of talked about this before as well. Basically just means if you have this fraction here, you can do the top and the bottom separately. You can split up a fraction to the top and the bottom separately. Also vice versa. So if you have it already split up, square root of 27 and square root of 3, and those don't work very nicely for you, make it a big fraction. 27 divided by 3 is 9, and then the square root of 9 will be 3. That'll be easy. Likewise, if it's already in one big fraction, you can split each one up separately. And in this case, they have the cubed root here. 6 divided by 3 is 2, or x squared. The third root of 8, or the cubed root of 8, is 2. Those go evenly separately, so in this case it's better to do them separately. So kind of that's an option you've got with division. You can either combine them together, top and bottom, and try to take the square root, or split them up. Let me see here. There we go. Okay, let me move my calculator here. Get it out of the way as much as I can. When you have fractions, though, and I think I've talked about this before, when you have a fraction, what you do not want, is to have a square root in the denominator of the fraction. So what you have to do is called rationalizing the denominator. Okay, rationalizing the denominator. So what that means is, here's a couple of instances where we could get a square root in the denominator, and here's what we would do. Okay, the first one, we've probably talked about this first one before. The second one we have to talk about a little bit more, but square root of b, that just can be anything. Square root of 5, square root of 7, any number. The b is just kind of a general term. You just multiply the denominator by that same exact thing, whatever that is. So in this case, my example here, 2 over the square root of 3. We don't like that. So I'm going to multiply by the square root of 3. Because what's the square root of 3 times the square root of 3? Well, it's the square root of 9, which can be simplified to 3. Okay, so that's going to just be 3. So whenever you multiply a square root times itself, it gives you whatever is under the radical there. Okay, so it's going to be 3. But in order to keep this fraction legal, we have to do the same thing on the top, and so what we have is 2 square root of 3. So this would be the form that we would want to have our answer in, 2 square root of 3 over 3. Okay, that shouldn't be too bad to you. Second part, this is a little trickier. This n out here, that's whatever other root it is. If it's not a square root, anything else, third, fourth, fifth, whatever, then, and here's your power inside, you're going to multiply both the numerator and denominator by this, which basically just means it's going to be the same index number out here, whatever this was, but the power inside, it's just you're going to take this one outside and subtract the exponents, this number minus that number. And here's kind of why that works. Because remember, I'm going to do this over here. Like I've got this cubed root of 2, right? Remember, the third root will cancel out the third power. So what we want to do is, if I can get this, the cubed root of 2, to be the cubed root of 2 to the third power, these two will cancel each other out, right? Well, right now over here, what do I have? I really have the first power. Okay, so what can I do there? Well, this is why you just multiply this times the same thing there, the cubed root of whatever you've got there. In this case, the same base, b and b, it's the same, 2, but we're going to do 3 minus 1, which is 2. Okay, so we kept the same index, third root, but I had 1, 2 here. I had 2 to the first power. I want to multiply it by 2 to the second power. It was whatever this 3 was out here minus the 1. That's how I got that 2. So what that really gives me then is the cubed root of 2 to the third power, which, what happens when we do that? The cubed root cancels the third power and leaves me with just 2. Just like before, to keep this legal, I have to, on the top, multiply this by the same thing, the cubed root of 2 squared. And what's 2 squared? 2 squared is 4. So basically what I've got here left is, I'm just going to skip the middle thing here, is 5 times the cubed root of 4 would be my answer on that one. Okay, so that's a little trickier, but that's what you do if it's not a square root by itself, like you've got up here. All right, moving on. Let's simplify a few things with fractions now, okay? We're going to try to follow this the same way that we did before. We might have to do some rationalizing of the denominator. All right, on the top, remember these we can, if it's one whole fraction, we can split it up to be square root of y to the 8th over square root of x to the 7th. We can do each one of those separately. Well, the top part's pretty easy. Remember how we did this again before? We can just do 8 divided by 2 is y to the 4th, pretty easy. The bottom doesn't work quite so easily because if I do 7 divided by 2, it doesn't come out evenly. So I'm going to split this up to make it x to the 6th, so that part will come out evenly. But then I also have one more in there, one more x, so another square root of x there, for a total of 6 plus 1 is 7. So what I have here is y to the 4th. 6 divided by 2 is x to the 3rd power, and then we've got that square root of x there. What's the problem now? We have a square root in the denominator, okay? So we've got to get rid of this. This is the first type that I said where it's just a square root of x. So what do I multiply by? The same exact thing, so I'm going to multiply by the square root of x. I also have to do it on the top. So what this leaves me with then is, on the top, y to the 4th, square root of x. Square root of x times square root of x is just x, right? So basically what I've got left there is just x to the 3rd times x, which is x to the 4th. And then we've got all this other stuff the same here. Okay? So some simplifying stuff there, rationalizing the denominator as well. Okay, let's look at one where we got a third root. Okay, so let's split this up separately. We've got the cubed root of 2. On the bottom, we've got the cubed root of 9x. Now, this, it's a little trickier, just, not much you can do here. But here's one thing that you can look for that might help here. You might be able to just go 9 times what would give me something that's a perfect cube. That's a little harder to kind of keep in mind. But if you notice here, if you have a 9, what's 9? 3 times 3. So I'm going to kind of break this 9 down into, I'm going to call it the cubed root of 3 squared. Okay, because that's what 9 is. And then we also have the cubed root of x. Okay, so both of these things are not really the best deal for us here on the bottom of our fraction. All right, so we're going to have to multiply by something that's going to get this cleared off and this. Okay, so remember our rule there. We're going to multiply by It's going to be the same index, so it's going to be 3. But to get rid of this part here, what do we have to do? Multiply by 3 to the power of what? 3 minus 2, which is 1. I'm not going to write the 1 there, but just the 3. This x is a first power. So on the x, what do I have to do? 3 minus 1 is x squared. So to get rid of the 3 squared, we want to make that squared a third power, so we multiply by 3 to the first power. To get this first power to be a third power, we have to go times x squared. That'll get that x to the third power. Okay? A little tricky there, but hopefully you see what we're doing. We'll probably go over that more in class as well. And so what this is going to give me on the bottom, really, here is what? Now when I multiply the cubed root of 3 squared and the cubed root of 3, I've got the cubed root of 3. Let me try this. Oh, rats. Every time I try to erase, I have to see if there's a setting for that. Okay, bear with me as I try to erase. So you've got the cubed root of 3 to the third, but then you've also got the cubed root of x to the third. When you multiply these, you see how you got this? So the cube root cancels out each one of the third powers, and all we're left with is just 3x on the bottom. Got rid of all the radicals. Okay, kind of tricky there. But if we did it here, to keep this legal, we have to do the same thing on top. And so in this case, remember, we can multiply the stuff underneath together, which in this case is going to be the cubed root of 2x squared. And there is nothing there that we can do to break that down any further, so we just have to leave that as the cubed root of 2x squared. Okay, we'll work on that some more, but that's the basic idea on that one. All right, onward. Just a kind of a quick little list here to remember kind of what you're doing when you're simplifying. Remember, the index is that little number outside the radical, so we want to make that as small as possible. If we can totally get rid of it, we're going to totally get rid of it. Where it says here the radicand contains no factors that are nth powers, basically that just means if you have the square root of x squared, okay, you don't want that power there, that squared power, because you can get rid of it. It's kind of similar to the first one. No fractions you see in the third one here. We don't want a fraction inside of our square root or our radical. And then obviously no radicals in the denominator of a fraction. Okay, so just a couple of things to look for there when we're simplifying. All right, let's talk about multiplying radicals a little bit. Remember what I said before, when we multiply, the stuff outside can multiply together, like the 6 and the 4 here, or the stuff underneath can. So you could, and again, just kind of depending how you want to approach this, but you could go ahead and multiply the 100 times the 10 and then try to see what you could do with the cubed root on that. Sometimes that's a little harder. Sometimes it's easier to kind of break things down or think about this a little differently. Remember what I did on that last example with the 9? You know, because we've got the cubed root of 100 and the cubed root of 10. Well, the 100, you go, hey, 100 is 10 times 10, or 10 squared, isn't it? So here's what I've got. I got 5 times the cubed root of 10 squared times the cubed root of a squared. Well, then we're going to multiply all that times the cubed root of 10 times the cubed root of a. So I kind of broke both these down. And an interesting thing that happens here that actually makes this pretty simple, you've got the cubed root of 10 squared and the cubed root of 10 to the first, which gives you what? The cubed root of 10 to the third when you combine these two here. And you notice those are going to cancel. And then you've got, let's see here, the cubed root of a squared and the cubed root of a to the first. Oh, well, that's going to give you the cubed root of a to the third. Interestingly enough, that is also going to work out evenly. And then the one thing here, don't forget about your little 5 sitting out at the front, so we also have times 5. And so what we're going to end up with at the end here is 5 times 10 times a. This gave you the 10 here because these canceled and give you the a. And 5 times 10 times a is 50a. Okay? All right, one more here. On this one, and again, sometimes, like in that case, I tried to kind of break it down, each one separately first. Now look at this one. You go, 8 and 2, we're thinking about square roots here. But if you look at this, you go, well, 8 times 2 is 16. That's a perfect square. So this time, we might want to go ahead and just multiply those first. So first of all, I'm going to do the outside stuff. 6 times 4 is 24. And then I'm going to go square root of 8 times square root of 2 is square root of 16. Square root of 3 times square root of c to the third times square root of c is c to the fourth. And then we've got d to the fifth and d to the third. That's d to the eighth. So now that this time it was a lot easier to just multiply the stuff together inside first instead of trying to do this. And again, the cubed root's a little harder. But then let's just simplify this. Here, what do we got? 24 square root of 16? 4. We got c to the fourth. The square root of that, 4 divided by 2 is c squared. 4 divided by 2 is 2. And then 8 divided by 2 is d to the fourth. Last step, 24 times 4. 96. So we got 96 c squared d to the fourth. Usually the square roots are a little easier to deal with than cubed roots and fourth roots and things like that. All right, moving on. Adding and subtracting now. Okay, this is actually not too difficult. It works just like you would have a variable. You know, remember how we talked about like terms? You know, if you have 4x plus 5x, it's 9x. Well, basically what we're looking for to add and subtract are like radical expressions. So basically that means the square root part or the cubed root part, I don't have an example for cubed root, but the square root part or the cubed root part or the fourth root part has to be exactly the same. If they are, you can just add the numbers out front. Okay? In this case, they're not the same. But could we perhaps simplify these square roots? Yeah, I think we probably could. So first of all, we got this 4 here. Square root of 8 could break down to be what? Square root of 4 times square root of 2. What's the square root of 4? 2. So basically we have 2 times 4 is 8 square root of 2. So we broke that 8 down, simplified that. What about the, here we have 3, what about the square root of 50? Oh, how about 25 times 2? Because the square root of 25 is 5. 5 times 3 is 15. And we have that square root of 2 left over. Now that we've broken both of these down and simplified them, look what we've got. Square root of 2, square root of 2. These are like radical expressions, okay? So what that means is it's just the same as, here I'm going to do a little example up here. This has nothing to do with this problem. But remember back when we had, instead of 8 square root of 2, let's say we had 8x plus 15x. When we added those together, what do we get? 23x. The x's work the same way as the radicals here, so we're just going to add the numbers out front, and our answer is going to be 23 square root of 2. Okay, it works just the same way as we used to do this with variables. Okay, that's not too bad, right? Let's look at one more, and then a few more things, and we'll be done. Just a little hint. Okay, Don't tell anybody. But on these kind of problems, typically that they give you in the book, a lot of the times, if you're not sure about how to break these down, and you see that one breaks down to be square root of 2, a lot of times another one will be a square root of 2. Or, you know, if there's a square root of 5, there'll probably be another square root of 5. So that's a good thing to look for, okay? Don't tell anybody. All right, what about square root of 45? Well, square root of 45, I could go 9 and 5. Oh, look, here's square root of 5 in this one. So square root of 9 is 3. 3 times 3 is 9 square root of 5. So here's where my little hint comes in handy. You think, oh, look, this one worked out to be square root of 5. Ooh, 80. Ooh, what do I do with 80? Okay, well, here's what we can do. Bring this over here. What we can do is we look at this and we say, well, I'm not really sure, but this was a square root of 5, so maybe this one would break down too. So let's just check this out. Now let's do 80, oops, 80 divided by 5. See what we get left over. Ooh, 16. 16 is a perfect square. So what that means is this could be then square root of 16 times square root of 5. So it just can make things a little quicker. You don't have to try everything. And square root of 16 is 4. 4 times 5 is 20. So minus 20 square root of 5. And then what about this square root of 20? Well, we could break that down to, of course, you have this 4 out here already, but then the square root of 4 times the square root of 5. Square root of 4 is 2. 2 times 4 is 8. And square root of 5. So now you notice what we've got left. Square root of 5, square root of 5, square root of 5. These are all like radicals, so all we have to do is add the numbers out front. 9 minus 20 plus 8. And you see that it looks like we got negative 3, so this will equal negative 3. Yikes. Okay, watch it. I'm going to try to erase. Dang it. Square root of 5. So negative 3 square root of 5. Okay? How are we feeling about that, okay? I hope so. Moving on. All right, now it gets a little fun. These last couple of examples now get a little fun. You know, we multiplied a couple of kind of basically polynomials together. Now what we kind of have are these binomials with radicals in them. Well, think back, what did we do before with binomials? We did FOIL. What do you think we're going to do this time? FOIL. Yay. Okay. So it's the same thing. All right, so let's go ahead. We're going to do first. And remember, the stuff outside the radicals can multiply together, and the stuff inside can multiply together. So in this case, we can do the 3 times 2. So we have 6 square root of 3. Outside, this time, the square root of 3 times square root of 3 is what we multiply together, which is square root of 9, or 3. So that's 3 times 2, which is 6, minus 6 because of this minus sign here. Then we're going to multiply these two. This 3 is outside, that 3 is outside, so this one has to be plus 9 square root of 5. And then last, the 5 and the 3 are both under, so those get multiplied together, so I'm going to have plus 3 square root of 15. Okay, so I FOILed this together. Now in this case, you look, I got a square root of 3. That's as simple as it gets. Square root of 5, simple as it gets. Square root of 15, we cannot break that down either. None of these are like radicals, so that's it. That's our answer. We just multiplied that stuff together, and we have to leave it like that. Okay, so foiling. All right, one more here, and then we got one last example that's going to deal with this. So really pay attention to what happens here. There's something, and you should know what's going on in this. We've kind of done it before with like imaginary numbers as well. Okay, I'm going to go first. So I go 7 times 7 is 49. Those can multiply together. The square root of 2 times square root of 2 is square root of 4 or 2. Okay, which that's going to give me 98. Outside, we go 7 times 3 is 21. Square root of 2 times square root of 3 is square root of 6. Inside, negative 3 times 7, negative 21. Square root of 3 times square root of 2 is square root of 6. And then finally, last, negative 3 times 3 is negative 9. And then square root of 3 times square root of 3 is positive 3. So times 3, which would be negative 27. Look what happened in the middle. Plus 21 square root of 6 minus square root of 26. Let me start that again. Plus 21 square root of 6 and minus 21 square root of 6. What do those two do? They cancel. So all I've got left is this is 98. And then this is going to be negative 9 times 3, which is minus 27. And when we subtract that, that's going to be 71. Look at that. No radicals in there. No square roots. Isn't that awesome? This is the key thing. What you just saw happen here. This is the key thing in our next, in our last problem here. But take a look at this before I change the slide. Look at these two things. They've multiplied together and got rid of all your radicals. Look at them. 7 square root of 2, 7 square root of 2. 3 square root of 3, 3 square root of 3. The only difference is what? Plus and minus. What is it called when they're the same thing, but one's plus and one's minus? Conjugates. Okay? And I've got this up here for you. Conjugates, basically you have that same binomial. We did this exact same thing with imaginary numbers. One's plus and one's minus. Okay? And as you can see here, the product of conjugates is always a rational number. That means, you know, it always gets rid of the imaginary when we did that. It gets rid of the square roots when we've done this. So here's why that's important, is because look at this. Remember when we were rationalizing the denominator before, and we either had a square root by itself or cube root or something? Now we've got a square root plus 3. Ugh. Okay? It's basically a binomial. So it's the same thing before that we kind of dealt with imaginary numbers, is what's going to get rid of this? If I multiply this by square root of 2, if I took this bottom thing here and I multiplied it times just the square root of 2, when I distribute it, yeah, that would get rid of that. It would be square root of 4, which is 2. But then I'd have to distribute the square root of 2 times 3, and guess what? I get another square root now kind of added back in there, trying to get rid of the first one. So what we have to do here is we have to multiply by the conjugate, which the conjugate of this would be square root of 2 minus 3. Remember what happened in the last example? When we FOILed those, we got a rational number on the bottom. So square root of 2 times square root of 2 is square root of 4, which is 2. When I do the out, that's minus 3 square root of 2. Inside is plus 3 square root of 2. And then 3 times 3, negative 3 is negative 9. What happens? Negative 3 square root of 2, positive 3 square root of 2. Those cancel. So what do I have left here at the end? 2 minus 9 is negative 7. It's gone. Okay, one last step then is to make sure everything stays legal here. I have to also multiply by the same thing on the top. So I'm just going to distribute here 5 times square root of 2. And so I distribute there, and then here minus 15. And depending on how you want to kind of switch this around here, I don't know how, I probably won't be real picky with this, but you know, notice how usually, that'll be fine. We can just leave it like this. 5 square root of 2 minus 15. There are times where as well you could probably do something with this negative down here. It would change both of these signs. or possibly have that in a different order, but that's okay. Just keep in mind, this is all we can do here, but just keep in mind, if this number here you get, say that 15, and this 5 here, if this on the bottom would have been, say, a -5, then that 5 and this 5 could divide out, and this 15 and that 5 could divide out. Remember how we could split up the two parts and divide each part separately? In this case, neither of these will divide by 7, and the key here is it doesn't matter what's under here dividing by 7, it's what's out here dividing evenly by 7, and this also dividing evenly by 7. Alright, that is it for this section. Hope you enjoyed it, at least a little bit. And that's going to do it for me, Mr. Anderson. I will see you next time. Take care. Bye.